a colonel. He's a NASA astronaut, and he is a member of the U.S. Space Force. He's going to lead us, and we're honored to have him join us. He wanted to meet all of you, and so we're honored to have him here. And he will lead us in the flag pledge, so please stand, everyone. And for those of you who are new, we face the large flag on the south wall. Colonel Hague, if you would.
I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Thank you so much, sir. Yes.
Welcome, pleasure to be with you.
So we're really going to let Colonel Hague tell us a little bit about himself, and then ask him if you have any questions. If you have questions about the Space Force, what that is, this is going to be your time to get some answers to those questions. So, Colonel, if you would just tell us a little bit about yourself.
Yeah, no. First off, I want to thank you for inviting me to participate this morning. It's a pleasure to be able to spend the time with you. And it's good to see such a large turnout. So where I grew up in western Kansas in a small rural town out on the farm in the middle of nowhere. But I had a dream of exploring. I had a dream to serve in something larger than myself, and that led me to the Air Force Academy and service in the Air Force. And I'm an engineer, so I'm not a pilot. I like understanding how things work. I like to break things. I like to put them back together. I like to make them do things that they haven't done before. And so I got involved in flight tests as part of my career in the Air Force, which led me in a natural overlap to try to apply for the space program. And so after a long, hard-fought struggle with the application process over the course of a decade and 3 applications, I finally got accepted into the Astronaut program back in 2013. That initial training culminated in a space flight to the International Space Station about 2.5 years ago. I went up there and spent 7 months on orbit conducting experiments and maintaining the space station as the national laboratory that it is. And following that, I came back and had an opportunity to do an assignment for the Space Force and helping stand it up as a new service. And I took that opportunity and also transferred into the Space Force. So I think what I'd like to do is just distinguish the difference between the 2 missions. So you see the Space Force background. I am a Space Force officer. I am assigned to NASA, and NASA has given me back to the Space Force to be able to help it stand up its test and evaluation program. So it's very complicated, but at the top level, Space Force does all those things that we depend on for our daily life. It provides us with navigation, GPS signals that power not only smartphones and tell you where to go when you ask Alexa for directions or you ask Siri for directions, but it also helps synchronize banking across the globe and provide timing signals. It provides communications and missile warning. All those services that underpin the security of our nation is what the Space Force provides. NASA has a civil mission to explore space, and because we have that protection for national security or for our nation that Space Force provides, we're able to do the NASA mission for exploring deeper into space. And so when I'm on the space station, I depend on Space Force to provide me with that same communications and navigation signals and to protect me from space debris. But I'm doing a separate and distinct mission. I'm exploring space. I'm learning about the universe and about the human body and how it behaves in space. I'm learning about the materials and how to make them better so that we can improve things on the ground and also help us eventually get to Mars. And so there's a distinct difference between the NASA mission and the Space Force mission, and I am really fortunate in that I get to transition back and forth between those 2 missions. Currently serving as the Director for Test and Evaluation for the Space Force. So I help run how we test all the new satellites and capabilities that we put into space. And then When I go back to NASA here, I'm due to rotate back in the summer. I'll go back to the astronaut corps and continue to support human spaceflight and hope one day to fly again. That was probably longer than a little bit, but I thought I'd share that. So I'm really looking forward to answering your questions.
Well, thank you so much. My gosh, can you imagine one human being doing all of that? He's young enough, though. Thank you so much,
It takes a lot
sir.
of help. It's a big team that makes this work,
Yeah.
trust me.
Gosh, we all want to know what space is like, don't we? Dan, I think you had a question. I know you did. Come on over here so he can see you.
Hey, sir, thanks for being here. I was wondering, does the Space Force recruit strictly from the Air Force, or are you guys recruiting from all the military branches?
That's a great question. So the Space Force is small. Let's start there. So the Space Force is 16,000 people, military and civilian. For comparison, the Air Force is about 800,000 people, military and civilian. So the Space Force is a very small fraction. When we stood up the Space Force, we essentially took the pieces that involved space out of the Air Force and consolidated them into the Space Force. And we're starting to pull parts from different services that have to do with space and consolidate those as well. And so those initial recruitments or transfers were predominantly from those units that we consolidated. So a lot of it came from the Air Force. But now that we've established kind of our steady state, now we're recruiting just like any of the other services do. We use a recruiting service, and so we're looking for high school graduates that want to enlist. We're looking for college graduates of ROTC programs that want to commission. The Air Force Academy serves as the service academy for both the Space Force and the Air Force. And so now we're more traditional in how we're bringing people in. Though we're new and we're looking to do things different. And so we're also looking at the challenge of being a small service is that I only need to bring in about 300 officers a year. So I can be really selective in how I do it. And so our process for screening and selecting the talent that we want to bring into the service is very competitive. I get to participate in the NASA selection process for astronauts. I think that the Space Force, the means that we're trying to find the right people, we go to the same lengths that NASA does to find the right group of astronauts. It's pretty selective.
Anyone else have a question? Yeah, I'll have you come up here, okay? Or if you can't, then I'll squeeze back there.
You had too big a crowd this morning.
Thanks, Sue. Good morning, Colonel. Is there a defining line between Air Force and Space Force? I mean, is it atmospheric? Is it geographical? Is it political?
Yeah, so
Bob would ask that.
I'm in the unique position that I have tested both sides of that line. So if you're looking at where we define the beginning of space, historically the Air Force has said that 50 miles up is the boundary between the air and space. The reality is that atmospheric drag becomes significant or less significant when you're about 62 miles high. So there's a little bit of disagreement between the international standard of 100 kilometers and 50 miles that the United States uses or the Air Force uses. So the way we define it is the international standard of 100 kilometers. And I keep mixing units because the rest of the world uses metric. So 100 kilometers up is where we say space begins. Because above that, and they call that the Kármán line, above that, drag is fairly insignificant. Now, I say that drag, so I saw the planes that you have in the back of the museum. So, those planes, they produce drag because they're flying through the atmosphere really fast, but they're only going, 500 miles an hour. The space station's going 17,500 miles an hour. And so even though the atmosphere is thin at 250 miles above the Earth, there's still enough molecules up there to produce drag. And so we routinely have to boost the space station, accelerate it a little bit more because it's slowing down because of drag. So imagine you've got a football stadium, because that's as big as the space station is. It's as long as a football field, and its solar array wingspan is as big as a 747 jet, and it's going 25 times the speed of sound around the Earth. That's what lets us go around once every 90 minutes. So I threw in some extra facts. Hopefully I answered your question though. 100 kilometers.
I think I had somebody over here with a question. I'm behind you. Hello. Here you go.
Yeah, good morning, Colonel. You can't give us anything on security that's classified, but down here we got the little robotic cleanup drones in everybody's home now. What are we going to do on the space side? Is there something anticipated or being worked on for taking out some of the garbage that's up there over time to reduce safety?
So space debris is a really big deal. So one of the missions that the Space Force conducts is called Space Domain Awareness. And they track everything that they can possibly track going around the Earth. And so that's about 40,000 objects as big as my fist. And trying to make sure that those things don't hit each other. A lot of that stuff is truly just junk at this point. It's pieces of old rockets that launch satellites into orbit, or it could be dead satellites. It could be pieces of satellites that, for instance, a few weeks ago, I think it was a month ago, the Russians decided to test an anti-satellite missile, and they blew up a satellite, and they created somewhere near 1,500 pieces of debris. So they took our 40,000 piece problem and they made it 41,500. And so that will continue to grow, and that's a challenge as we go up there. So I can tell you that in the research and development area, as we're looking for new technologies and trying to address future problems, space debris and how to get rid of it, how to mitigate it, how to do things to prevent it from occurring are high on our priority list.
Well, Colonel, I can't tell you how much. I'm going to take one more question because we have so much going on today. So let's let you do one more. And then we're going to talk the Colonel into coming back and being our keynote speaker.
Hello, sir. It's good to meet you. Thank you for doing this. My question kind of dovetails into the other gentleman's question. How often does a space station get struck by debris?
Yeah. So I mentioned that the Space Force is tracking everything that's bigger than my fist. There are things that are smaller than my fist that we can't track. And so when I was on the space station, I did 3 different spacewalks. And one of the things that when you're going through training, they tell you about is you got to be very intentional about where you grab. Part of that could be because the piece of metal's been in the sunlight and it's really, really hot. You don't want to melt your rubber glove. Could be really, really cold. Or it could be where what we call a micrometeorite or a piece of debris has hit the space station. And so imagine something the size of a grain of sand going, say it's going 17,000 miles an hour, and it strikes a metal handrail. So there are all over the space station places in the shielding of the space station where you can see something has hit it, and it looks like it's a precision drilled hole on one side, and then if you look on the back side of the shielding, it looks like a gun is shot through it, and so you've got the splayed metal that is jagged, and so you never want to grab your rubber glove on that jagged backside of that hole, otherwise you could slice your spacesuit open. And so, but you saw those all over the space station. So it gets hit routinely by little stuff, but we've designed it to withstand the little stuff. The big stuff, when the Space Force sees something coming, they give us enough warning that we get out of the way. And we move the space station around the other debris. If we don't have enough warning, then, and we've only had to do this a handful of times, if you don't have enough warning, then you go to your spacecraft, your capsule that took you up there, you get in your capsule, you close all the hatches, and you wait for the potential collision to occur. And if it does, then you're already set, ready to come home. If it doesn't, then you go about your normal life. So you hunker down in those cases. So debris is a big challenge. Hey, Sue,
Yes.
if I could ask one question real quick.
Absolutely.
Would it be possible, I saw at least one person that looked under the age of 15 in there running around. Can I get a question from one of the kids in the room? If there is
These
one?
are all kids, I hate to tell you. Listen, you don't know them like I do. And we're all deaf, you know. It's one more year. We don't have any little kids, you know. We do? Oh, come here. Come here. Here we do have one. And then could we, after this, because we have to move forward with our program, could we invite you to be our keynote speaker at one of our Kilroys? We have them the first Tuesday of every month. And if I could, you know, then these people could start planning on questions that they want to ask and this sort of thing. And so we'll work together on what month works for you, and we'll have you do that, okay? We would love it. Thank you so much.
Perfect.
Okay, here you go.
Were you in space?
Is he in space now? Oh.
I was in space, so I've launched to space twice. My first launch, and I launched to space on a Soyuz rocket. So I launched to space from Russia, Kazakhstan to be exact, in the same launch pad that Yuri Gagarin launched from. And Yuri Gagarin was the first person to launch into space. So I launched on a Russian rocket in a Russian spacecraft, speaking Russian, and went up to the space station and spent 7 months there, and then landed back in Kazakhstan and flew home on Delta Airlines.
Okay. Thank you so much. I hope that answered your question. We might have a future astronaut here. So let's thank Colonel Hague again for being here with us. We look forward to having you come back and have a lot more time with us. Thank you.